Have you ever wondered how rockets work and how they are able to reach space? It's a question that has fascinated humanity since the dawn of the space age. Rocket science, the intricate dance of physics and engineering that launches these massive structures into the cosmos, is a symphony of complexity and beauty. At the heart of this symphony lies the principles of physics and engineering, governing the propulsion that thrusts these spacecraft beyond our atmosphere. Understanding these principles isn't just about satisfying our curiosity, it's about unraveling the secrets of the universe, stepping towards the future, and pushing the boundaries of human innovation. From the explosive combustion that fuels the journey to the delicate staging that carries a spacecraft into orbit, every aspect of a rocket's journey is a testament to the marvels of scientific achievement. Ready to blast off into the world of rocket science? Hold tight, it's going to be a thrilling ride. To begin our journey, we must first understand a fundamental law of physics, Newton's third law. This law, posited by Sir Isaac Newton in the 17th century, is a cornerstone of our understanding of motion. It states quite simply that for every action, there is an equal and opposite reaction. But what does this mean in practical terms? Imagine you're sitting on a swivel chair and you push off a desk. What happens? You move backwards, away from the desk. That's Newton's third law in action. The force you exerted on the desk, the action, resulted in an equal force pushing you in the opposite direction, the reaction. Now let's take this concept and apply it to something a little more complex, a rocket. Rockets, you see, are not so different from our swivel chair. They move forward by expelling gas backward with a force. The force of the gas being pushed out of the rocket's engines, the action, results in an equal force pushing the rocket in the opposite direction, the reaction. It might seem counterintuitive. After all, how can something move forward by pushing something else backward? But that's the beauty of physics. This principle is what enables rockets to move, to escape Earth's gravity, and to travel through the vast reaches of space. Without Newton's third law, space travel as we know it would be impossible. Rockets wouldn't be able to generate the necessary thrust, and they would remain firmly grounded. So next time you watch a rocket launch, remember the simple principle at work. The massive flames and billowing smoke you see are more than just an impressive spectacle. They represent the action that propels the rocket upward, the reaction to the force of the gas being expelled. So in essence, rockets move forward by expelling gas backward with a force. It's a classic case of action and reaction. Now that we know the basic principle, let's delve into the heart of the rocket, the engine. The engine is where all the magic happens, where raw materials are transformed into the extraordinary force that propels a rocket into space. It's a fascinating process, so fasten your mental seatbelts as we take a closer look. Rocket engines produce thrust through a process known as combustion. Combustion, in the simplest terms, is a chemical reaction that releases energy in the form of light and heat. When you strike a match, you're witnessing combustion. When you see a firework explode in a burst of color, that's combustion too. But in a rocket engine, this process is controlled and harnessed to create forward motion, or thrust. The ingredients for this combustion are fuel and an oxidizer. The fuel, which can be a solid or a liquid, is what burns. It's like the wood in your fireplace, or the gasoline in your car. The oxidizer, on the other hand, is a substance that triggers the burning of the fuel. It's like the oxygen in the air that allows the wood in your fireplace to burn. In the confined space of the rocket engine, the fuel and the oxidizer are mixed together and ignited. This causes a violent chemical reaction where the fuel and the oxidizer react with each other and produce a massive amount of heat and gas. This gas expands rapidly and is forced out of the back of the rocket at high speed. According to Newton's third law of motion, for every action, there's an equal and opposite reaction. So as the gas is pushed out backward, the rocket is pushed forward. This force, this push, is what we call thrust. It's the power that lifts the rocket off the ground and keeps it moving upward against the pull of Earth's gravity. The more thrust a rocket engine can produce, the heavier the payload it can lift, and the farther it can travel into space. Without this powerful thrust, overcoming Earth's gravity would be impossible. So next time you watch a rocket launch, remember, it's not just a spectacle of light and sound. It's a demonstration of the incredible power of combustion and the scientific principle of thrust. Have you ever noticed that rockets are usually made up of multiple parts? That's not a design flaw. It's a secret weapon called staging. Let's dive into this fascinating concept. Staging is like peeling an onion, layer by layer. As a rocket ascends into the sky, it sheds parts of itself, much like a snake shedding its skin. This isn't because the rocket is falling apart. Instead, it's a carefully planned and executed strategy. But why would a rocket need to jettison parts of itself during the ascent? The answer lies in one word: weight. The heavy fuel needed for liftoff becomes dead weight once it's used up. The rocket has to work harder to lift this unnecessary weight, burning even more fuel in the process. It's a vicious cycle. That's where staging comes in. By discarding the used-up parts, the rocket becomes lighter and more efficient. It's like a long-distance runner shedding heavy clothing as they heat up during a race. Each stage of the rocket has its own engine and fuel supply. Once a stage's fuel is depleted, it's jettisoned, and the next stage ignites. It's a relay race to the stars. This isn't a new concept. The Saturn V, the rocket that took humans to the moon, had 3 stages. The first stage, with its 5 massive engines, burned for just 2.5 minutes before being jettisoned. The next 2 stages took over, each doing their part before being discarded. Staging isn't without its challenges. The timing must be perfect, and the separation must be clean to avoid damaging the rocket. But the benefits far outweigh the risks. Without staging, we wouldn't have been able to send astronauts to the moon, rovers to Mars, or probes to the outer reaches of our solar system. In the end, the principle of staging is a beautiful testament to the ingenuity of human engineering. It's a delicate dance of destruction and creation, of shedding the old to make way for the new. Staging allows rockets to shed unnecessary weight, making it easier to reach the desired altitude and speed. Reaching space isn't just about going up. It's about going fast enough to stay up. But how fast is fast enough? Well, let's take a moment to talk about the concept of escape velocity. This term might sound like it's straight out of a science fiction movie, but it's a very real and crucial aspect of space travel. So what exactly is it? Simply put, escape velocity is the speed that a rocket needs to reach to break free from Earth's gravitational pull and not fall back down. Imagine you're throwing a ball up in the air. It rises, slows down, then falls back to your hand, right? That's because Earth's gravity is pulling it back down. But if you could throw that ball at around 25,000 miles per hour, it would have enough speed to overcome the pull of gravity and keep going, never falling back down. That's escape velocity. Now, when we're talking about rockets, we're not just throwing them up and hoping they reach this speed. A lot of meticulous planning and engineering goes into ensuring that a rocket can reach and maintain this high velocity. Rockets are designed to carry and burn fuel efficiently, providing enough thrust to reach these incredible speeds. And it's not just about reaching this speed once. To stay in orbit, a rocket needs to keep up this pace, constantly falling toward the Earth, but moving fast enough forward to miss it. That's what being in orbit is, a constant state of falling and missing the Earth, all thanks to the magic of escape velocity. So the next time you watch a rocket launch, remember that it's not just about getting high enough to reach space. It's about going fast enough to stay there, racing against the pull of Earth's gravity at a speed of 25,000 miles per hour. Achieving orbit isn't just a matter of altitude, it's a game of speed. Getting a rocket into space is no easy feat. There are countless challenges to overcome, from atmospheric pressure to temperature extremes. Let's delve deeper into these hurdles that rockets must surmount to make their way beyond our planet. Firstly, atmospheric pressure is a significant barrier. As a rocket ascends, it has to push against the weight of the atmosphere. This not only requires a tremendous amount of energy, but also puts enormous pressure on the rocket structure. The rocket has to be sturdy enough to withstand these forces, yet light enough to be propelled upwards. It's a delicate balancing act that engineers have to perfect. In addition to atmospheric pressure, rockets also face temperature extremes. The moment of liftoff is accompanied by a fiery blast of heat as the rocket engines ignite. This intense heat can reach thousands of degrees, posing a risk to the rocket's integrity. Then, as the rocket ascends and leaves our atmosphere, it encounters the cold vacuum of space. These sudden shifts from extreme heat to extreme cold can cause materials to contract and expand, potentially leading to structural damage. Speaking of the vacuum of space, it presents its own set of challenges. In the absence of air, traditional aerodynamics don't apply. Rockets have to rely on the principles of momentum and reaction forces to navigate through this void. Additionally, the vacuum of space also means there's no air to help dissipate heat, which can cause parts of the rocket to overheat. The journey to space is fraught with challenges, each more daunting than the last. But these aren't insurmountable. With every launch, we learn more about these challenges and how to overcome them. Engineers continually refine their designs, innovating and adapting to meet these obstacles head-on. Despite these challenges, advancements in technology and engineering have made space travel possible. It's a testament to human ingenuity and our unquenchable desire to explore the unknown. So the next time you gaze up at the night sky, remember the incredible journey each rocket undertakes to reach those distant stars. Rocket science, as we've seen, is a fascinating blend of physics, engineering, and a dash of courage. It's a symphony of scientific principles, each playing its part in the grand spectacle of space exploration. Let's take a moment to revisit the high points of our journey. We began with Newton's third law, the foundation of rocket propulsion. For every action, there's an equal and opposite reaction. It's this law that allows a rocket to push down on the Earth and, in return, be propelled upwards. Then, we delved into the fiery world of thrust and combustion. Thrust, the force that propels a rocket, is generated by the combustion of fuel within the rocket's engines. This reaction produces a tremendous amount of energy, which is expelled out of the rocket's exhaust, propelling the vehicle in the opposite direction. Next, we uncovered a rocket's secret weapon, staging. This ingenious design strategy allows rockets to shed weight during their ascent, making the journey to space more fuel efficient. It's like shedding layers of a heavy winter coat as you get warmer. Overcoming Earth's gravity is no small feat. It requires a tremendous amount of energy and precision, which we discussed in detail. The gravitational pull of the Earth is a formidable adversary, but with the right amount of thrust and the right trajectory, a rocket can break free and sail into the cosmos. Finally, we touched on the challenges of space travel. From the harsh conditions of space to the difficult task of re-entry, these challenges require innovative solutions and brave explorers willing to face them. So the next time you watch a rocket launch, you'll know the science that's propelling it into the cosmos. Thank you for joining this journey through rocket science. Until next time, keep looking up. Before we wrap up, remember that learning is a journey, not a destination. If you've learned something new from our voyage through rocket science, give this video a like and share your newfound knowledge. Your opinions matter to us, so we encourage you to share your thoughts and questions in the comments section below. Can't get enough of space exploration? Don't forget to hit that subscribe button for more enlightening content. We're all in this universe together, so why not share this video with your friends and family? Let's inspire curiosity and wonder in more people. Until the next adventure, keep looking up and keep exploring.